Hello guys, it's Cong here. Today I'll be talking about a coding standard that we should apply within our team. I think this will help us organize our code better in a more professional manner. So this is by no means final. If you find if you have any improvements on this model I'm proposing, or if you find some like giant loophole or bug, let me know. So I'm just taking what I usually do either on co-op or by myself. When I get a fairly large sized project that I'm starting from scratch, like from the design. Let's get started. The development process will be divided into 5 main phases, and they're listed as a design, pre-implementation, implementation, documentation and testing, and continuous optimization. So before I actually get into each of the phases, usually this is how would I organize the project file. Like, not usually how would I, but like I made some changes based on how the team should work. So the project root folder will be whatever all the project files stored in. That will be the main root GitHub folder, for example, and it should have a design folder underneath it, which holds the preliminary design stuff, which are done in the design phase. Also a folder including all the source code that we have, which is named after the project name. For example, it would be WarBots SSL, WarBots 2D, etc. And then different folders for related tools. Those will be like for the SSL team, we have the GRSim simulator. That will be listed on the same file as well, just so we have all the tools when we download this entire project. And also like a README file. So within the design folder, which is the most important thing, we have different files, program flow, core features, regular features, class list, and prefix list. Don't worry, there will be an example about it. So let's talk about the design phase. So design phase, we should complete a flow of the program, which is just a rough flow. So just line by line, like a sequential order and exactly flow of the program, and followed by some more detailed description. So that like right now how we're doing this is that we're just talking about it, and now this is actually documented down into a file. And the main idea here is that we just jot it down somewhere so we can keep a reference. And the optional flowcharts, which are under the image folder, under the design folder, which I don't have any for this example that I'm going to show you guys right about like soon. And list of features, and they should be divided in terms of importance. For me, I divided them into core features and regular features. The difference here is subtle, but my idea is that the core features should be something that you have to have solid in order to move on. So for the soccer team, it will be getting the information, getting the communication, getting the input, and the computation should be one of the regular features. Because if you're getting the wrong information, you cannot do, even if your code for the computation is perfect, it will still give you the wrong results. So there's a break there, somewhat a break. And then we have the list of classes and structures, which are in the class list file. Basically, a description of each class is, maybe some important methods should be listed there as well, and a prefix that we'll use in our naming convention. So for example, here, this will be the program flow file. Let me turn up the font size for you guys. Okay, there we go. Okay, so this example is a small size league SSL. So what SSL is a league where it's still a soccer AI playing league, but the difference is that the vision system is global, so that every player sees the entire field at once. That's the main difference compared to other leagues. So here's a quick program flow. So this project uses a 3-level AI system, and world information is provided by GRSim or SSL Vision. So GRSim is a simulator, SSL Vision is the actual camera feed, and RefBox, which is basically an automated referee, which gives you the play mode and etc. So this is the flow. So main initializes and runs a coach class, and coach fetches info, calculates, updates whatever whatever class we use for the information, selects a strategy, and then coach selects a strategy to implement based on the current play. So this is a decision AI. And strategy configures and assigns roles or tasks to players based on this information, which we call the implementation AI. And the players execute their roles or tasks based on whatever information. So that'll be the low-level AI. And then some notes here will be, well, just basically Jerison provides detection information, robotics if you play mode, which basically I already said. I'm missing the more detailed paragraphy description, but this is suffice. This gives you an idea how the program should run, and mentions some of the core classes that we have to be using. Yeah, and then we go to the core features, which is the communication and input. Here is code should be able to retrieve detection info and play mode info, which is by listening to UDP sockets at the appropriate ports. And then code should be able to update the information, and that will be distributed to strategy and players. So they'll be able to update the memory, maybe update the player status, and yeah, using physics model here to update the player status. So that's the important stuff, getting all the information there before we move on to the computation and all the AI stuff. So this must be solid. So this, after all these are done, there should be a sort of a simple testing to see that we're actually getting the correct inputs to everything. And also, like, I'm skipping a lot of stuff here. There should be a lot more in this features list because these should be long lists, but this is just an example. So for regular features, there'll be strategy should be able to assign roles or tasks. Basically, we'll talk about the main stuff in the program flow. And also, the player should be able to translate those roles to commands. Player should be able to send commands. And for the simulator, it'll be UDP sockets, and for the actual robot, it'll be using TCP sockets. Okay, and for players should be able to move, kick, all those features. So this list should be gigantic. But like I don't have time to type all of those in. This is an incomplete list to begin with. And for class list, I only did one example, which is a coach, also a field state. So this is the class name and the prefix that we'll use in the naming convention in the bracket afterwards. So coach, I use coach. Just coach is sort of like a singleton. You should only declare one instance of it. Maybe two if you want to run two teams against each other, which is the reason I didn't make this a singleton class. But yeah, like, so the prefix is coach, it's long, but whatever. So we have a short description of what you should have, which has to list own players, team name, memory structure, and the library of strategies. So when you have has something, it should be a member field. Able to do something, it should be a method, a feature that the coach should have. So member fields, like a string of team names. So this is not actual code. This is like idea. So string of team name, int of the ports that you actually receive information from and listen to. A vector of all the player classes, library. Custom means this is a library that we're developing ourselves. I mean, this is a class. Sorry, this is a class that we're developing ourselves. So I'm not sure how to implement libraries yet. It should be a tree because you have different decisions. And a vector of decision info should be custom as well. And here it should be the field states. And just note, field state has the play mode inside. So we're wrapping both the information into one class and sending that down to our strategies, to our players. Pointers of latest detection info. This is basically the field state that you'll be passing down to players and strategies. And some examples, some methods. For example, you fetch the serialized string of the vision packet, and for the ref packet, this is Google protobuf stuff. And then update memory, basically doing the physics calculation stuff. This is important. Updating players, give them the newest information, etc. You know, this is a short list of what we expect in this class. That should be the class list, and then prefix list should be just the prefixes of whatever class it will be. So a global variable should be a prefix with a G, numbers N, booleans B, string, and then you see strategy is strat, field state is fs, etc., etc. This goes on. And I'll give you an example of variable naming when we have to give you the example for documentation, like the actual the structure of the code.